the co-founder of terrascorekids.com, and today we are going to discuss a very important topic of R, which is R data types. So without any delay, let's get started. I'm minimizing the screen. Oh, sorry. Right. And I'm going to place my screen here so that you can see me clearly as well. R data types. Perfect. So, in programming, data type is an important concept. Variables can store data of different types, and different types can do different things. In R, variables do not need to be declared with any particular type and can even change type after they have been set. Right. So what does this mean? Like in last time I told you what are variables? Variables are containers, and if you have a container of rice in your home, so like if you have a variable of rice in your home, so the container is the variable and rice is the data that you are saving, right? So that data that you're saving in that container, what type of it is? Is it something to be played with? Is it something to be eaten? Is it something to be is it something to be drunk? Right? So here we in R we have different data types. And that different data types do different things. Like there you have two containers. One container is of rice and the other container is of toys, right? So that data type of rice, it is used to eat, right? And the container which has toys, that data is used to play with, right? So just like this in R we have variables that store different data types, right? And those different data types do different things. So it's also saying that in R variables, if we have given a value to R, I mean a variable, like I've given a value to my var as 30. So we can change its value to Sally, a string, right? From a number to a string. So we can change its value, okay? And one more thing, it's not important that you have to say my var string. Like basically, you don't have to define the type. R understands itself what type it is, okay? So here, for example, we have a variable called my var, which value is 30. So we have assigned a value. Now we can even change it by giving it a string value or whatever data type value you want, right? So R has a variety of data types and object classes. You will learn much more about these as you continue to get to know R, right? Basic data types. So here now we are going to know the basic data types of R. So basic data types in R can be divided into the following types: numeric, integer, complex, character, and logical. So numeric means, like, I'll tell you. Yeah. So in numeric, you can say that it can also be a floating point number, like a decimal number. It can also be an integer, a normal number. But let's try one thing because this might come in your mind, that what if I give a negative number? Is it still, what type is it? Let's see. It is a numeric type, right? So in what do you say, numeric, you can even have decimal type number, negative numbers, positive numbers, basically integers, right? Now another type is integer itself. 1L, 55L, 100L. Oh my god, what is it saying? What is L, right? So where the letter L declares this is an integer, right? So like you put an L so that the computer gets to know the R, R gets to know that you're making an integer, not a numeric, right? Let's see something, that can an integer we can give a negative value? Yes, we can. And let's see if we can give a floating point number. in an integer data type? No. Okay. Integer literal 10.00L contains unnecessary decimal point. So it's saying that this decimal point is not allowed. So you may be saying, what about here? It's actually kind of very obvious that you cannot put decimal points. So here it's again that you cannot put decimal points anywhere when you're using an integer and when you have given an L at the back, right? Now, complex. 9 plus 3i, where I is the imaginary part, right? So this took me also a lot of time to understand, and this is an advanced topic, so we will come back to this later. I'll make a separate video of this, right? Even though it's going to take me about a 5-minute video, but this topic is supposed to be cleared, right? So I'll make a separate video for this also, in which I'm explaining only complex, right? Now character, aka string. So character is basically string, you can say, in which you have to in whatever thing that you put in quotes, that is string, and string is also known as characters in R, right? So that data type will show character and not string. Okay. Even a number you can put in a string, that then also it will be known as a character because it's in quotes, right? Now logical is aka boolean. This means that logical is known as boolean in no, sorry, boolean is known as logical in R, which is true or false, right? So the class function is used to check the data type of a variable, right? So here look, this is a numeric type, this is an integer type, this is complex which we will understand later, this is a character because this is in quotes, and this is a boolean, so it's known as logical in R. So yeah. Alright, so you will learn much more about the individual data types in the upcoming chapter. Okay, so in the upcoming chapters, we are going to understand. And by the way, complex is not really important. I don't think you're going to you're going to need it. But if you comment below, then please make a video of complex. No problem. Okay. Now, our numbers. So, numbers, there are three types of numbers: numeric, integer, and complex. Variables of numeric types are created when you assign a value to them. So, numeric types, like now, the numeric types are those types in which we use an integer also. In integers we also take negative numbers and positive numbers and zero and a decimal floating point, right? In integer we have to give an L at the back, and we cannot put decimal floating point numbers, right? And complex we are going to understand here, right? Okay, so this is an example of complex where one I, right? So we are assigning this value. Numeric. A numeric data type is most common type in R and contains any number with or without decimal, like 10.5, 55, 787. We have already discussed this, so let's get ahead. By the way, this is an example. We are making two variables. One is 10.5 as the value and the other has 55. As these both have numeric data types values, so when we print x and y, we get 10.5 and 55. And when we find out the what type is it, we are going to get numeric. Okay. Now integer. Integers are numeric data types without decimals, right? So they're kind of like the same thing, just without decimals, and you have to give an L at the back because maybe you're making a variable here like this, right? And you have not given an L, so R can get confused that is this a numeric numeric type or is this an integer? So to make to so that R knows, we put an L at the back so that it knows that it's an integer. Okay. Now complex. A complex number is written with an I as the imaginary part. So you can just say that complex are the same things, but with just an I, it's just an imaginary part. It's okay. They're not in such a use because it's just an imaginary part for us. You just put an I so that we know that it's a complex, right? So yeah, so this is complex. Did you understand complex? If not, then don't think that, oh my god, what is this? She has not made me understand. If you have understood that, very nice. If not, then complex are basically numbers with an imaginary part, and we write that imaginary part with an I. So basically, you will not use complex at all, right? So you can just leave this if you want to, because uh, it's in complex, it's the same thing, it's an integer just with an I as the imaginary part. Okay, it's not doing anything. So type conversion. So like, you have a data type, sorry, you have a variable which type is numeric and you want to convert it into an integer, right? So how will you do that? So you can convert from one type to another with the following functions. So we have functions to do this. If you have a complex number, complex data type, so complex data type value of a variable, and you want to change it to a numeric. So here are the functions that you are going to use to do conversion of these data types, right? So you have one variable x, which has an integer value as 1l, and y, which is a numeric value which has 2. Then a is equals to as dot numeric x, right? So x is an integer, right? So we are converting that integer to a numeric, and that numeric is being saved in the variable a. Okay. B as integer y. So it's the same thing, like y is a numeric type, so it's going to convert into an integer because we are using that function, and that value is going to be saved in b, right? So then we are printing x and y, it will get 1 and 2, y as 2, because while we're converting, we're not changing, you know wait, nothing, actually we are changing the once again. Oh, wait. It's actually going to get the same thing. Look. So, I by mistake, I was getting a bit confused. You know, it's as we have changed the value of x and y, its value is changed, but the new value, that new value of x and y is being saved in b also, and x and y also have the changed value of them. Okay. So in class A we have a numeric, and class B we have an integer. Okay. Okay. So this was numbers. Let's go to the next chapter, which is R maths. Simple math. In R, you can use operators to perform common mathematical operations on numbers. So basically, there are operators in R which we can use to do mathematical operations, right? The plus operator. The plus operator is used to add together two values, right? 10 plus 5, what is 15, right? Now you might have a question that First, let's check this. It's an error because you cannot, what is the error? Error in 10 plus 5 non-numeric argument to binary operator, right? So this is not a numeric, numeric, it's a string, right? It's a character. It's not a, what do you say that? Yes, it's not a numeric anymore, right? That is why it's getting an error, right? If you think that maybe I, you know, try to concatenate, so it's not going to work. Look, all right. Now here we have a subtraction operator from which we can subtract two values. All right. So built-in math functions. So in maths we have some built-in functions that R has already made for us, right? Even though we can make more functions to do a particular thing, we have built-in math functions if we want to use them. Okay. So we have min and max, right? So what do you think min and max does? Yes, max gets the highest value from the set and min gets the lowest, basically the smallest. Max gets the highest, the greatest value from the set, and min gets the smallest or the lowest, value from the set. Okay. Here you see, here 15 was the biggest number and here 5 was the smallest, right? So it has got that. Now square root. So what does the square root function does? It returns the square root of a number, right? So square root of 16 is 4, right? 4 into 4, 16, right? Square, then you might think, what is the square root of 25? Can you guess? That's very easy. 5, correct, because 5 into 5 is 25, right? Now apps. The apps function returns the absolute positive value of a number. So in the apps function, if you have a negative integer, so it will return you a positive number, right? Alright, and you might think, oh, if that's true, can we get a positive number to an integer number from apps? No, you do not. Absolute is only used to convert a negative integer to a positive integer. If we already have a positive integer, so it will just print it like that. Okay. Now, ceiling and floor. The ceiling function rounds a number upwards to its nearest integer, and the floor function rounds a number towards the nearest integer and returns the result, right? So you might be thinking that the ceiling will get 1 and the floor will also get 1, but that is wrong. From the ceiling, it rounds off the decimal number to the towards upwards, like basically 1.4. If you round it off to downwards, so it will come 1. But if you round it upwards, so it will get 2, right? So 2 and 1. That's what ceiling and floor do, okay? Now are strings. String literals. Strings are used for storing text. A string is surrounded by either single quotation marks or double quotation marks. So it's saying that strings are basically texts, storing text. They are used to store text, right? And if you put the same string into double quotes or the single quotes, it is same, right? Just like this example, it's going to print hello and hello, right? Assigning a string to a variable. So that's very easy. You give a variable a string value, a character value, and then you just print it. Super easy. Multi-line string, you can also assign a multi-line string to a variable like this. You have string and you put the string like afterward, like in line and line, it's multi-line string, right? So here we can assign a multi-line string to a variable, but eventually it's going to get this. Oh, one second, it's going to, you know one second. Yes, it's going to get a whole string like here, right? In one, it's going to get it like this horizontally, the whole thing. It's not going to give us line. All right. However, the R will add, this is, n at each line break. This is an escape character, and the n character indicates a new line. If you want if you want the line break to be inserted at the same position as in the code, use the get function. Okay. So here, what it's saying that this is an escape character, okay, and when we give n in front of it, that means that we want it in a new line, right? And if, like I was telling you, that whatever how big the line is, it will get the whole thing like it. If you wanted to get the output just as the way we have written, you will use the cat function, right? Now you might be thinking, can I do this? Can I? Let's see. Wait. Oh, sorry. I gave the wrong escape character. That was what I was thinking. Will it work? Right. Yeah, it's just getting a new line after it, right? If you want to give a new line here also, and here also, and here also, right? If you want to, if you want to give a new line over here also, right? So it is used to get new lines, right? And cat, what does the cat function does? The cat function gets the code exactly the way it has been written at the same position, right? Now string length. So there is an nchar. Okay, there is an nchar function to get the string length. So if you have written a hello world and you want to see how what is the length, right, of this character. String is also known as character, if you can remember, right? So I'm using character almost everywhere, because then only you're going to get the hang of it. So str hello world, and if you give nchar string, it is going to get 12 character. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. Now if you think that, comment down below what will be the string length. For you it should be 14, right? That, oh my god, why is it getting 13? That must be in your mind. That is because this is an escape character, right? And this escape character, in front of anything that you give an escape character, if you give a new line on sorry, if you give a new line on anything, it will understand that you're trying to format your string, right? So this is kind of like an escape character which is not counted, right? N is counted but not that escape character, right? So that is why it is getting 30. Check a string. Okay. Use the grepl function. What a cool name. Function to check if a character or a sequence of characters are present in a string. Right? So you use the grepl function to see if that particular thing that you're seeing is in your string or not, right? Like for example, h. It will go here, check, is there h? Yes, there is h. Is hello here? Yes, there is hello. Is there X? No, there is not. So true, true, false, right? Combine two strings. So to combine two strings, we use the paste function, right? I was telling you up that can we in our math that can we combine two strings from the plus operator? No, we have a separate function for this, which is paste function, right? All right. Now escape characters. Now are escape characters. To insert characters that are illegal in a string, you must use an escape character. Like for example, that we put an N, right? You put an N to get a new line. So you will have to give an escape character so that it can recognize, oh, you're trying to get a new line. It's not a part of the string. You're just trying to get a new line, right? An escape character is a backslash followed by the character you want to insert. An example of an illegal character is double quote inside a string that is surrounded by double quotes, right? So sometimes, now, just one second, guys, I'm just coming in a second. Alright, guys, so sorry for the disturbance. Right, so what I was saying that if we do this single quote, right, and sometimes sometimes it is like Saiasmi means channel, right? So in some cases, you want a quote, it's needed, right? So in this condition, we are getting an error because in single quotes, another quote that is not allowed. If you think, oh, she's trying to do that, let's close this. Will it work? See, no, it won't. Okay, because you can't put single quotes into single quotes and double quotes also not in double quotes, right? Okay. To fix this problem, use the escape character, right? If you want to get the quotes in your string, you can use the escape character, because of which now we can use quotes inside here, right? So we are so-called Vikings. To get these what do you say quotes, you will have to give an escape character, then then an escape character, then the quotes, right? So it will just get it will just get it the way it should get, right? Yeah. You might be first thinking that why is it getting this? It is because we are printing str here, because of which this is also getting printed, right? But when you do cat str, we want it the exact way, at the exact position. The escape characters do not come the way we want, right? Now, note the auto printing, the str variable will print the backslash in the output. You can use the cat function to print it without backslash. I've already told you. Other escape characters in R are this is backslash, this is to get a new line, this is to get a carriage return, this is to get a tab, and this is to get a backspace. Okay? You can try these on your code. Okay? This is your homework for today. Now the last topic is R booleans, which are also known as logical values in R. Okay? So booleans. In programming, you often need to know if an expression is true or false, right? So basically, you just say that logical values of booleans are just true or false. If a condition is true, do this. If it's false, do this, right? This is booleans. true or false, only two values. Okay, and after that, whatever you want to do. Okay, like, is 10 greater than 9? True. Is 10 equivalent to 9? No. False. Is 10 less than 9? No. False. Right? So here it has got the output, right? You can also compare two variables, right? So from what do you say? From booleans we can also compare two variables. Like, one variable is a, we have 10 as its value, and b as its value 9, and here we can compare, is a greater than b? True, because 10 is greater than 9. Right. When I was telling you that, if a thing is true, do this, if it's false, do that, that comes in the if statement. Okay, so here we have a and we have b as variables, 203 33, right? We will learn about if and else later on, but it's just an example to make you understand where we use booleans, right? So here we have two variables, a and b. One has 200, the other has 33, right? If b is greater than a, if b is greater than a, is b greater than a? No. So it won't go in the if statement only, it will go in the else statement and print b is not greater than a. It might be that you might not understand, and it might be it you might understand if you have done programming languages or seen my other videos. It's okay, because we are going to learn about if and else over here also. Okay, so guys, this was it for today. I hope you liked the video, and I'll see you next time. Bye.